Welcome to part 1 of our lesson on the substitution rule with regards to integration. So the substitution rule, this introduces a problem-solving strategy of introducing something extra, meaning a new variable, which will change the value of x to a different variable called u. So this is where if u is equal to g of x is a differentiable function whose range is an interval I, and f is continuous on I, then the integral of f of g of x times g prime of x dx is equal to the integral of f of u du. And this looks very similar to our differentiation formula with regards to the chain rule. So for example, what the heck this means, we have the integral of 2x times the square root of 1 plus x squared dx. So for us to do this substitution, we want to let u be 1 plus x squared. And taking the derivative of u, so the differential du, this would be equal to 2x dx. And it just so happens that in this integral, we have the 2x dx inside of it. So we do not need to do anything extra with regards to this integral. So to actually compute this, we are going to apply a substitution. So this is the integral of the square root of u du. So that is easy enough for us to compute. This is the same thing as the integral of u to the 1/2 du. And applying the formula, this will be 2/3 times u to the 3/2 plus c. And resubstituting back in here at the end with regards to what we have here for u, this will be 2/3 times 1 plus x squared to the 3/2 plus c. And here's another one. The integral of x cubed times the cosine of x to the 4th plus 2 dx. So here we're going to let u be in the parentheses of the cosine here. This would be x to the 4th plus 2. So now when we take the differential du, this would be 4x cubed, but we can see that the only thing that we have here is the x cubed dx. And there's a dx here at the end. We only have the x cubed and the dx, no 4, right? So we need to slightly change this to apply the substitution correctly by dividing by 4 on both sides. So this is the same thing as 1/4 du is equal to x cubed dx. And now that matches. So since that matches, we can now apply this. And this is the same thing as 1/4 from what we had to take out by dividing by 4 times the integral of the cosine of u du. And this will be 1/4 times the sine of u. And resubstituting back in here at the end, this is 1/4 times the sine of x to the 4th plus 2. And we have the plus c at the end, based on the integration constants. And here's another one. Indefinite integral, the integral of x cubed times the square root of x squared plus 22 dx. So For this, we're going to let u be x squared plus 22. And because of that, we can also slightly manipulate this to be that x squared is equal to u minus 22. And taking the differential of u, du, this would be 2x dx. Again, though, looking at this, we don't even have, well, either the x or 2 inside of this integral, but we could divide by 2 at the very least to get something slightly more usable. And this is a half du is equal to x dx. So before we can even substitute, we need to break this up a little bit. We could write this as, since we have an x squared, when we manipulated that first substitution, we could factor out an x squared from this x cubed term. This would be the integral of x squared times x times the square root of x squared plus 22 dx. So now we could apply our substitutions, right? This is going to be a half from the manipulation that we did times the integral of, we have x squared here to be u minus 22. So u minus 22 times, we have u to the 1/2, since we have u being the x squared plus 22, du. Because now we have the x dx from what we have up here. So applying this now, this integral, this is going to be a half times the integral of distributing the u to the 1/2 to the binomial we have here. This would be u to the 3/2 minus 22 times u to the 1/2 du. So this is going to make, applying this integration, 1/2 times 2/5 times u to the 5/2 minus 22 times 2/3 times u to the 3/2 plus c. This can be slightly simplified to be 1/5 times u to the 5/2 minus 22/3 times u to the 3/2 plus c. And then resubstituting here at the end, this is 1/5 times x squared plus 22 to the 5/2 minus 22/3 times x squared plus 22 to the 3/2 plus c. And let me just fix this 3. As the integral that we obtained for this particular problem. So while what we are doing is all fine and dandy, those were for indefinite integrals. For a definite integral using the substitution rule, if g prime is continuous on the closed interval from a to b, and f is continuous on the range of u is equal to g of x, then the integral from a to b of f of g of x times g prime of x dx is the integral from g of a to g of b of f of u du. So what does that mean? Well, here's an example. Example, evaluating the integral from 0 to 4 of the square root of 2x plus 1 dx. So we are going to let u be 2x plus 1, and our differential du would just be, well, 2 dx. But since there's no 2 in that, we're going to divide by 2. So this would be 1/2 du is equal to dx. So when we're applying this now, right, we would have 1/2 times the integral of, this would be u to the 1/2 du. But now for the terms of our integration here, the beginning and ending point, we could change them, right? So let's start with this 0 here. Since we have the formula here, we could apply that to change the terms of integration. So this would be 2 times 0 plus 1. So the value we're going to use for the lower end of this integration is the value of 1. Likewise, for this value of 4, this would be 2 times 4 plus 1. And that gives us a value of 9 for the upper limit of our integration that we are finding. So this is 1/2 times the integral from 1 to 9 of u to the 1/2 du. And this is 1/2 times, this would be 2/3 times u to the 3/2, which will be 1/3 times u to the 3/2. Now, typically we would substitute back into x, which we could do to solve the original problem. But since we changed the terms of integration, we could just use the new terms now as opposed to the old ones. So we're going to evaluate this between 1 and 9. So this will be 1/3 times 9 to the 3/2 minus 1/3 times 1 to the 3/2. And when you compute that, you should get a value of 26/3. Let me know if you have any questions or concerns, and I'll see you for part 2. Thank you.